for this session, and let's continue with chapter 6. I hope everyone has watched the lecture video. Where is my share screen? It's here. Chapter 6, circular motion, share. Okay, so we are doing chapter 6, but I'm going to do it very fast because you are supposed to have watched the video already. Macam mana nak screen? Biasa tak pakai mic. Okay, so does anyone have any questions about the video that you watched yesterday? Assuming everyone watched it. Okay, no questions? Okay, I'm going to continue. Okay, so for chapter 6, let's go over it briefly. We know that our circular motion has 2 dimensions. And why is it 2-dimensional? Because at this point, we have a y component over here, v to y. And we also have a x component over here. So it's 2-dimensional. Your circular motion is 2-dimensional. So that makes it hard when you want to describe the velocity of your ball, right? So that is how we have your angular velocity. So this is your angular velocity. Yep. Soalan ke? Siapa ni? Muhammad. Tak nampak nama dia apa. Okay. So that is why you have your angular velocity, which describes your velocity as the change in angle over the change in time, instead of Vx equals to something, Vy equals to something, right? So it's hard to describe it like that. So they introduce angular speed, which is the change in the change in theta over the change in time. So let's say I start from this point and my final point is this. So the change in delta is this guy, right? At this point, my angle is, let's say it's 20, and at this point, the angle is 90. So my change in delta is 20 minus 90, right? Final minus initial, I'm moving this way. So 20 minus 90. So I'm moving in the opposite direction, in the negative direction. And it is negative 70. So I'm going clockwise, okay? So the positive and negative depends on the direction lah, okay? So if you're going clockwise, it's negative. Ni negative lah, kenapa positive? Okay, ada convention for this. You will learn this in chapter 7, so don't worry about the positive or negative yet. So what you need to know here is your angular velocity describes delta theta, which is the change in angle over the change in time. Okay, and it is frequently mixed up with frequency, angular frequency. Boleh juga. Okay, we will also see that one as well. So you know the V equals to R omega. We've seen this equation, and you can also write it like this. Omega equals to 1R over V, or V over R. This part is derivation, which leads to mv squared over r. I won't go over the derivation. If you want, you can do that on your own time because we are trying to catch up. Okay, so remember, we have a tangential velocity, right? We have tangential v, and our tangential v is v1, and at this point it is v2. The magnitude of v is the same. Magnitude of v is the same, but the direction is different. For V1, it is going this way, and for V2, the direction is going this way. Remember, we learned for vectors, for a vector to be equal, the magnitude must be equal and the direction must be equal as well. So with that in mind, for an equal vector, magnitude and direction has to be the same. So V1 is not equal to V2 because they are vectors and they have different directions, which means that V1 is not equal to V2. If I were to subtract V2 with V1, I will get some value. It's not going to be 0, even though the magnitude is the same because it's a vector. Why do I have some value even though the magnitude is the same? Because for me to subtract a vector, they must be in the same direction. And how do I get them in the same direction? I must resolve them. So here I have to resolve V2x minus V1x, some x value. Vy, v2y minus minus v1y, and there is some vy value. So a vector that does not have the same direction is not equal to 0. Okay, so that is how we have delta v over here. So when we have a delta v, which is our tangential velocity keeps on changing over this circular motion, and it is over time, which is delta t, we have average acceleration, right? We've learned this before. When we have a change in velocity over the change in time, we will get acceleration. Why do we have change in velocity? Because the vectors are not equal. If the vectors are equal, they have the same direction, they have the same magnitude, this would be equal to 0. My acceleration will be 0. But now their direction is different, which means that I have acceleration. And that acceleration is centripetal acceleration. Okay, so using the same equation, when my time is really small, which means that my v1 is here, my v2 is over here. The time is really, really small until I can't see it. It's like a single dot. Okay, so when it is super small, it becomes instantaneous acceleration. And similarly, this is known as centripetal acceleration. So centripetal acceleration is the instantaneous acceleration towards the center. Okay, tadi kita derive average, right? But the instantaneous is more accurate to describe centripetal acceleration. That is all that you need to know here. And then there is some derivation to get this equation. AC equals to V squared over R. You can find videos online if you like to know how it is derived. For me, it is very counterintuitive. It's hard for me to explain it to you without confusing you at first, and that's going to take time. And trust me, this won't be on the exam, so I'm not going to teach you so that we can catch up with other classes. So here you need to know AC equals to V squared over R. Am I recording this session? Oh yes, I'm recording it. Okay. So what equations do we have now? We have V equals to R omega. We have omega equals to delta theta over delta t. And we have AC equals to V squared over R. Okay, so those are the three equations that you need to know. Okay. So AC, the direction is always towards the center of the circle. Always towards the center of the circle. Okay, and this is where it's very important for you to start writing equations later. This example is easy. You know that the center of the circle is here. So this is where your FAC is. So my condition is net in the radial direction is MAC, and which is equal to FAC lah. FAC is just MAC. And substituting AC with V squared over R gives me MV squared over R. This is an easy example. Here, the only thing that we know acting in the radial direction is T. Is there anything else? There's no R. Mg is not in the radial direction. So the only force acting in the radial direction or towards the center for this particular case is tension of the spring. So here, Fr is also equal to T. This means that my MAC is equal to T, or MV squared over R equals to T. Okay, so that's an easy example. Okay. Centripetal force changes the direction of velocity. We know this. We have tangential velocity with the same magnitude, but the direction keeps on changing because there is a force that is pushing this velocity towards the center, which makes the V change direction. If centripetal force vanished, which means that my string snapped, the tension of the spring is no longer there, my ball will fly off in the direction of V tangential. It's not going to move here, it's not going to move backwards, it's going to move in V tangential. If my string snapped over here, my V tangential is this way. If my string snapped over here, my ball will fly this way because that is the direction of V tangential. Remember, your ball has a velocity. that keeps on changing because of centripetal acceleration. If the tension is not there, it means that you do not have MAC. If you don't have MAC or you don't have centripetal acceleration, your ball only has velocity. And when you only have velocity, it will follow in the direction of V tangential. Okay, let's take a look at other examples. Okay, this one. Okay, so here, your direction of AC, you are swinging an airplane by a string. The center, the direction of centripetal acceleration is towards the center, right? You are actually down here. This is you, and this is your string. And this is your airplane. Okay, somewhat. Wow, teruknya. Okay, airplane macam tu lah. Okay, so this is bad. This is my string. This is not a string, this is the circular motion. Now, the center of this circular motion is here. Why? Because this is where I would calculate my radius. Okay, so the place that I would calculate my radius or the center of the circle is where the direction of my AC is. So this is also the direction of AC towards the center. It's not here, it's not here, it's not AC here, it's not here as well, it's wrong. Even though this guy is pointing towards the center, that is not the circular motion. Where is the circular motion? The circle is up here and the center of this circle is here. So this AC is pointing towards the center. Okay, that's an example. Okay, so padam dulu. So now that we know that our AC is towards the center, it's here, right? Ini top view. Tadi saya tunjuk side view. So top view AC is that way. And we know that there is a string, T. So T is actually the string and AC is here. Betul tak? FAC or FC, centripetal acceleration. FC, and you have tension going here. And this is your airplane. So this is your free body diagram. So now your, oh kat sini dia punya ni dia buat horizontal. Sorry, saya kasih example yang susah. Sorry, my bad. This is actually a horizontal string. So this is me over here. I have a horizontal string and this is my airplane and it moves. Kiranya tak ada angle lah. Okay, so tension is this way, AC is also this way. So that is why this equation is like that. So FR equals to MAC. What is acting in the radial direction over here? Here your AC is towards the center. Saya tulis terbalik. Wait. So AC is this way. Okay. So AC is towards the center. This is your circular motion. Your T is this way, and your AC is also that way. So MAC equals to T, mv squared over R equals to T. Okay, because T is the only thing that is acting towards the radial direction. Okay, kenapa saya tersilap T tadi? Sebab saya imagine daripada sini. So T is always pointing towards the center, right? Center of the string. So T is this way from the airplane. From the airplane, it's this way. From your side, it's this way. So we are talking about the airplane. Saya tersilap part tu. Okay, so T is this way. Okay, tension always points towards the center of the string. Your T is pointing towards the center of the circular motion. AC is also pointing towards the center of the circular motion, which means that MAC is in the same direction as T, so T is a positive, it's not a negative. Okay, so mv squared over R is T. So that is easy because of the angle. What if you have an angle? Dun, dun, dun. So where is your center of circular motion? Can anyone tell me? Is it here? Is it here? Is this your center? Where?
That's T.
That's T, betul. So your center of circular motion is down here. Walaupun tak ada string kat situ, walaupun it's just air, there's a center there because that is where you would calculate your radius. Betul tak? This is your radius of your circular motion. If that is your radius, that is your center of circular motion. So this object punya AC is pointing towards the center, which means that AC is in this direction. And your T is this direction. T is pointing towards the center of the string. T is this way. If you are measuring it from, if you have an object here, your T is this way, but your object is down here. So your T is going upwards for this guy. Okay, so that is your T. And this is your AC. So now we know that this angle is theta over here, and using your modern maths knowledge, saya tak nak ajar ni pasal kan, cakap modern maths terus. So this angle is theta as well. Okay, remember, if you have a Z, if this is theta, this is also theta. So here, this is your Z. Okay, so this theta is equal to this theta. So the person that is touching the angle becomes the cosine, and the other guy becomes the sine. So in your condition is Fr, net force in the radial direction, is equal to mass times centripetal acceleration. And the forces acting in the radial direction is T sine theta, because T sine theta points towards the center. So T sine theta. Now you have an equation MAC equals to T sine theta, or mv squared over r T sine theta. Okay, you can rearrange this however you like, but the important thing here to know is you need to know how to resolve T in the radial direction. So this is chapter 3. Okay, if you don't remember, please revise. So this is T, my T, I want to resolve my T, so the guy that touches the angle becomes a cosine, the other guy becomes a sine. So T sine theta is pointing towards the radial direction or towards the center. So MAC equals to T sine theta. Okay. Yay. So the angle theta increases as the speed v increases. Why? Your mass does not ever change because, yes, you just have a ball over there. Your radius, well, it can change depending on how you are trying to swing it. Your radius changes when your angle changes, right? So the angle theta increases as your speed increases. So you can imagine you are swinging this. If you are swinging it slowly, your angle is small, right? Kalau kita buat slow-slow, kecil je bulat dia. Kenapa jadi cone pula ni? Okay, so it moves just in a small circular motion. But when you increase the speed, the angle increases. The angle becomes wider. So now you have a bigger theta. Your V increases, your theta increases, your R also increases. Your radius, right? So that's something to think about. But the important thing to know here, as I said before, you just need to know how to write the equation. Fr equals to MAC. And what is acting here? T sine theta. Sama macam chapter 3. Only that it's in radial direction. Tu je. Okay. And of course, you will get your values for the equation. So, tak ada lah nak kena tulis-tulis, nak kena rearrange ke apa ke, tak ada. Alright, so now we have another example, car on a circular curve. When a car goes around a curve, okay, this is your curve, there must be a net force towards the center of the circle. Okay, kalau kita ada circular motion, we will always have centripetal acceleration towards the center. So here, my circular motion is this way. So the center of the circle is here. So here, if the road is flat, the force is supplied by friction or static friction. Okay, so here I have, this is my car. This is R because I'm on a surface, so I have reaction force. And this is mg. Okay, mg is weight, your gravitational force. And then in your radial direction, you have friction. This is Fs. Radial. In your radial direction, you have static friction, sorry, your equation becomes Fy equals to 0. You are not flying, you are not going upwards, you're just on the road, right? So your tangential net force is 0, or your vertical net force is 0, and positive R minus mg, which means your R is just mg. Okay, that's your first one. And then your Fr, which is the net force in your radial direction, is MAC because you are moving in a circular motion. What is acting in the radial direction? It is static friction, Fs. You know Fs is mu R, right? Mu R or mu SR, okay? Mu S because it is static friction. So this guy, we know R is mg, so you can just replace mu with mg, okay? So here mv squared over R equals to mu mg. I can cancel out m. So v squared over R is just mu g, or however you want to rearrange it. So this guy dia rearrange jadi v equals to square root of mu rg. Okay, boleh juga mu rg square root. Get your v. Kenapa static friction is in that direction? Can anyone tell me? Does anyone have an idea why we have static friction if we are on a flat road and we want to have a circular motion? Kenapa kena ada static friction?
Kalau tidak kita ke dalam.
Dia nak kita ke dalam. Sebab kita nak ke dalam, betul? Is that your answer?
Kalau tak ada friction tu like macam kita bergerak ke dalam lah kan?
Kalau tak ada friction tu kita bergerak ke dalam. Ke dalam tu apa? Macam mana, tak faham?
Kat center dia.
Kat center dia. Kejap.
Ni doktor. Static friction dia ke dalam supaya kita stay berpusing. Kalau tak nanti kita keluar daripada lilitan bulatan tu.
Betul. Okey, betul. Kalau kita ada static friction yang memaksa kita ke dalam, V tangential akan ke dalam kan? Tengok tadi. So cara nak bayangkan ni is imagine jangka lukis lah. Tahu kan jangka lukis tu apa?
Oh.
Tahu ke jangka lukis tu apa? Tahu ke?
Tahu.
Dalam map tahu. Okay, so untuk buat bulatan, korang kena ada jangka lukis tu punya satu center tu korang kena tak gerakkan, macam static kan? Yang ni kena static.
Tajam.
Pusing. So kalau tak static kat sini, tak boleh pusing, betul tak? Tak boleh buat circular motion tu. Betul tak?
Betul.
So, sama juga konsep dia kat sini. Ada benda yang kena static ke arah dalam so that you can go in a circular motion. So that is what is happening for that car. So this guy, benda yang bagi ke dalam tu ialah static friction lah. Okay. So tu je cara saya nak bagi ingat. Sebab benda ni tak intuitif. Bagi saya it's hard to imagine. So saya would imagine jangka lukis. Jangka lukis kena ada static kat tengah. That is what is happening for the car as well. You have static friction pointing towards the center for you to have circular motion. Okay? Okay ke? Okay ke?
Okay, faham.
Faham eh?
Okay.
Okay, good. Okay, tadi ni rearrange je. Okay, so tadi kita punya example ada friction and it was flat. Now kita punya example is ada at angle theta and frictionless. Tak ada friction eh. So how do we write our AC ataupun our centripetal acceleration. Okay. Saya rasa saya nak lukis kat tempat lain kejap New slide. Okay. So kita ada this banked curve. Awak punya kereta dia macam ni sebab dia sengit sikit sebab dia bank curve. Tapi daripada top view, your car is moving macam cerita F1 tu lah. Macam ni, kat bawah ni dia ke dalam. Dia macam cone. Okay, ke dalam. Faham tak saya cerita ni? Dia ke menjunam ke bawah lah. Kan macam ni kan. Ni side view, ni top view. Okay, so you have a center that is at a lower position than where your car is. Okay, ni point A, ni point A. Atas ni point B. Okay, ni side view, ni top view. Okay, so your car is moving dalam satu kawasan yang bulat tapi dia condong ke bawah. Okay, where is your AC pointing towards? Is it this way or is it this way? Number 1 or number 2? Where is your AC pointing towards?
Number 1.
Kenapa?
Towards the center of
Towards the center of the circular motion. Okay. Ada jawapan lain lagi tak? Where do you calculate your radius? Where do you determine your radius?
number 1.
Dua. So you have a circular motion. Where is your radius? Atas ke bawah?
Atas.
Atas kan?
Atas.
It has to be the same level as your circular motion. Baru jadi radius. Okay, so if your radius is here, which means that your AC is also here. Okay, so AC is number 1. Betul. Okay, so we want our AC this way. Bukan want lah, memang AC kat situ pun. So this is our AC, F, E, C. For this free body diagram, we also have mg in this direction. Our R is perpendicular to the surface. As always, we know this from chapter 3. Previously for our chapter 3, we said, okay, this guy is theta, and this is mg cosine theta, and this is mg sine theta. Can I resolve my R? Is it?
Yes.
Yes. What is
Yes.
the angle over? Allah. What is the angle over here? Boleh I can resolve my R. Saya nak buat angle macam mana ni? This is perpendicular. This is in this direction. Okay. What is the angle over here? Is it theta or not? Or is it 90 minus theta?
Is it theta?
It's theta. Isn't theta?
Yes.
It's theta.
Mm-mm.
Okay, so it is theta. Bawah ni theta, atas ni pun theta. Okay. So this is in the same direction as mg tau. Tahu. Jangan salah pula. So this is straight over here, down here, sama. Yang ni R sama dengan mg cosine theta. Okay, so the angle over here is also theta, betul. So how do I resolve this? Apa-apa yang touching angle will become cosine. Sama juga. And for this guy, it's if you resolve your R, it will be over here, R sine theta. Nampak tak? mg kita resolve, mg cosine theta here, mg sine theta here. R kita resolve, R cosine here, R sine theta here. This is 90 degrees, this is 90 degrees. Walaupun tempat yang berbeza. Sebab tu dia tak overlap. Okay. So tu saya baru resolve R dengan mg je. Baru resolve belum lukis tulis equation lagi. So now, how does my equation look like? So here, untuk solve a circular motion equation, your Fy equals to 0, which is your tangential velocity. Tangential force. and your R is MAC. Okay, so in the Y direction, you have R cosine theta positive minus mg, because R cosine theta is going upward, mg is going downwards. So your mg is equal to R cosine theta. Okay, so you solve that. Untuk FR, radial direction punya net force, you have MAC. What is in the radial direction? We already dah lukis dah siap-siap. FAC is this way. R sin theta is in the same direction as your FAC. So you have positive R sin theta. R sin theta is in the same direction as FAC, which gives it a positive. Now your R, now you have MAC equals to R sin theta. Mg, okay. R is equal to, R is equal to mg over cosine theta. Okay, ni saya rearrange dia. R equals to mg cosine theta sebab saya nak substitute masuk dalam ni. So now this becomes, alamak tak cukup tempat. This becomes okay, so R saya ambil ke sini, mg cosine theta, sin theta. And you know sin theta over cosine theta is just tangent theta. Kita dah nampak ni banyak kali. Sin over cosine is tangent theta. mv squared over R. Cancel out. So you get your tangent theta equals to v squared over R divided by G. Okay. Kalau tak nak rearrange macam ni pun tak apa. Tapi apa yang penting kat sini is knowing how to write this equation and this equation. Paling penting. Values boleh masuk kemudian, arranging the equation masuk kemudian. Yang penting you have to know your free body diagram and writing the right equation. Any questions about this one? Macam confusing sikit kan? Sebab ada kena resolve dua benda. Okay, it's just resolving. Okay, don't panic so much. Okay. Alright, so kalau tak ada question, I'm gonna move on.
Saya ada question.
Okay.
Kalau untuk yang tu, kalau guna mu R, kan sebab friction kan mu R, so lain yang dapat.
Kalau ada friction, kalau soalan ni ada friction, you will get your Fs this way, right? Betul tak? So you have to solve your friction force juga. Which makes it super complicated. 2 resolve pun dah pening. 3, macam itulah. Your static friction will always oppose the motion. It will always be on the surface. Friction force is always on the surface. So it's not in the same direction as your FAC. It's this way. So you need to know what is the angle here. And then resolve your Fs in the FAC. So kalau ada Fs, your Fs becomes Fs cosine theta, static friction. So this guy becomes positive Fs cosine theta. Okay, jadi complicated lagi lah. But most of the time,
No, Dr. I mean macam untuk R sin theta tu tak boleh guna mu R ke?
R sin theta tak boleh pakai mu R. Mu R kan friction. Mu R. Kenapa nak pakai mu R? R sin theta bersama dengan mu R. Sekejap. R sin theta sama dengan mu R. Awak cakap kenapa tak boleh pakai yang ni? Mu R kan friction. Kita punya soalan frictionless.
Bukan tadi sebab macam kalau yang kereta tu kita guna mu R kan? Tak
Kalau kereta yang ada friction, yes, kita pakai mu R. Kalau sekarang ni frictionless, dia tak ada friction. Awak tanya kalau dia ada friction ke? Ni frictionless.
Dia macam saya confuse sebab tadi pun untuk yang kereta yang tadi kan dia bila macam guna mu R untuk dia punya mu R equal to
C.
MAC. Tapi yang ni kenapa tak guna mu R equal to MAC?
Sebab mu R tu friction. Kan, mu r tu friction. So friction pointing towards the center. Okay, so MAC equals to Fs. Betul lah, mu r. MAC equals to mu r. Tapi untuk yang ni, dia tak ada friction. No friction. Fs equals to mu r tau. Ni friction punya equation. Sekarang ni friction tak ada. So MAC awak tak ada friction. Yang ada hanyalah komponen R, which is R sin theta. Kalau static friction ada, boleh. But static friction is in this direction, and in this direction, your static friction is Fs cosine theta lah. So kena tambah kat sini, Fs cosine theta. Boleh je. Lepas tu, awak tanya kenapa tak boleh cakap R sin theta tu sama dengan Fs cosine theta. Kenapa awak cakap kenapa R sin theta tu bukan static friction, betul tak? Sebab your R has a component. Kalau kita lukis free body diagram pun, macam nak cakap? Kita ada angle. Sekarang ni kita resolve R dekat sini. Kita resolve R tau. R tu ada komponen. Kalau soalan ni ada friction, friction pun ada kat sini. Your F is not equal to R. F and R are different things.
Oh, faham.
Okay. So yes, F equals to mu R, but in the AC direction, there's R sin theta. So kalau awak cakap F equals to mu R sekalipun, in your AC direction, MAC is still R sin theta plus Fs. Kalau Fs awak mu R lah. Tapi most likely it's not lah. Sebab R ni is a force as well. So you have to have it in your equation if it's there. Friction is also another force, but it is related to R. Okay, so kalau dua-dua ada, dua-dua kena ada dalam equation. Okay, is that clear? Confusing ke?
Yes, thank you, Doctor.
Any other questions?
Dr. Nat, the direction of friction is always towards the center.
Not really, depending on the situation. Tadi, yes, towards the center. This one is towards the center. But in this case, it's going downwards. Tapi soalan ni kata tak frictionless kan? So, tak ada lah. Okay, your friction cannot be in the air. Your friction is always parallel to your surface. Kena ingat tu. So here, your surface is here, friction is here. Your surface is down here, friction is down here. Okay, tak boleh in the air. It's not possible to have friction in the air. Okay, there's only air resistance, but kita tak cover dalam ni. Okay, is that okay? Fs always parallel to the surface. Okay, sama juga macam R is always perpendicular to the surface. Fs is always parallel to the surface. Okay, right. So I'm going to move on.
Thank you, Doctor.
Okay. Alright, tadi kita talked about a car. Yeah.
So, sorry to interrupt. For just now, we solve the R. Is it because we want to get the radius is perpendicular and parallel to our cos?
Yes, we resolve the R because kita nak tahu all the forces that is acting in the radial direction. So kalau kat sini, we know that our R has a component in the radial direction, but our mg does not have any in the radial direction. So sebenarnya kalau saya tak nak solve mg pun boleh. But if I don't resolve my mg, I will not know that my R cosine is equal to mg. Tapi boleh je lah sebenarnya. Sebenarnya tak payah resolve mg pun untuk cerita ni. Okay, because R cosine theta is just mg. I did not have to resolve my mg. I just wanted to relate back to chapter 3. So the only component and acting in the radial direction is just from R. So I had to resolve R. If my mg is in the radial direction, I will resolve mg in the radial direction. It depends on the question. Is that clear?
It means that we need to resolve the force so that the force that we resolve in x direction and y direction is parallel or perpendicular to the radius. Is it mean like this?
Lagi sekali, cakap kuat sikit, tak dengar.
Or we need to resolve the r but not the weight because we want to make the force is perpendicular and parallel to the radius of center.
Yes.
Alright. Alright. Thank you, Doctor.
Okay. Sebab for our example, we are not flying, which means that our Fy is equal to 0, right? We are not moving upwards, we are not moving downwards, which means that we are in equilibrium in the vertical position, but we are not in equilibrium in the radial direction. So F radial direction is not in equilibrium, which means that we have acceleration, centripetal acceleration. That is how we have the circular motion. Okay? Itu je.
Okay.
Okay.
Thank you, Doctor.
Welcome. Okay, so now we have a vertical circle. So here, how do we have R when we are in the air? Can anyone tell me how? Macam mana kita boleh ada reaction force even though we are up in the air? How do I have this R?
Doctor, because we have weight.
Because we have weight. Well, if I'm up in the air, flying, I have weight, but it doesn't mean I have R. I don't have R when I'm flying. Okay, so jawapan tu tak tepat. Siapa lagi boleh jawab kenapa I have R when I'm on the Ferris wheel?
Because the frame of the Ferris wheel acts as the surface.
Yes, or the seat, the seat of the Ferris wheel. I'm sitting on the Ferris wheel, or the Ferris wheel punya rangka tu, it becomes my surface. When I have a surface, I have R. Good. Betul. Okay, so now my R for a Ferris wheel is always pointing towards upwards. Dia tak pergi condong, dia tak ke kanan, tak ke kiri. It's always upwards. Because my seat, the Ferris wheel punya seat does not ever adalah juga kadang-kadang dia condong-condong tu kan. Tapi most of the time it's always upright. It's going upright walaupun it's in a circular motion. It's moving upright. Question? So
No.
Tak ada. Okay. So you are always, your chair is always in the upright position. So your R is always upright. Okay, walaupun you are moving in a circular motion. That's the first thing you need to know for a Ferris wheel punya problem. R is always pointing upwards. Okay. Okay. So R is pointing upwards, mg is going downwards. Where is my AC pointing towards? Is it going here? Or is it down here? Is it here? Is it here?
mg equal to mg.
mg, yes, it's pointing in the same direction as mg because AC always points towards the center of the circular motion. This is my center. Okay, so to write this equation, Fr equals to MAC. That is your condition for a circular motion. What is acting in the AC direction? The forces acting in the radial direction is positive mg because mg is pointing towards the center, minus R because R is going opposite direction as the AC. Okay, apa-apa yang terbalik daripada AC, it becomes negative. So now my equation becomes MAC equals to mg minus R. If I were to rearrange this, R equals to mg minus MAC or mv squared over R. Betul tak? Okay, betul. Okay. So here, dah tulis sini. R equals to mg minus mv squared over r. Now, what happens if my r is a negative? Can my r be negative? Can I have a negative r on a Ferris wheel?
No.
Why not? Why
It will
not?
mean that we would fly from the seat.
Yes, it means I'm flying off from the seat and I'm dead. So tak nak macam tu. We always want to be safe. Our R needs to be positive at all times. Okay, if you don't want to be dead, your R needs to be positive. So mg minus mvr, for this guy to be positive, your g, okay, factoring out m, because m does not change, your g must be greater than v squared over r. Which means that at the highest point, your V must be really slow. Sebab kalau dia laju sangat, it will overcome G and you will fly off. So your V has to be slow. So if you can imagine the Ferris wheel kat atas ni, dia selalunya macam gerak tak gerak sangat kalau kat atas sekali. Gerak tak gerak sangat because it doesn't want you to be dead. Okay, so it needs to be really slow for G to be greater than V squared over R. Okay. Okay, so at the lowest point, let's see. So R is still upright, mg is this way, but now your AC is here. Okay, so sama juga FR equals to MAC. Walaupun redundant, it's very important sebab selalunya orang lupa. Orang lupa yang ada MAC kat sini. Okay, so what is acting in the AC direction? Positive R, because my R is now in the same direction as AC, minus mg. So now my equation becomes MAC R minus mg. Rearranging this gives me R equals to MAC plus mg. So can my R be negative for this equation? Tak, because dia tambah, dia takkan jadi negatif lah. So this guy is V squared over R plus G. This guy will always be positive. So kalau kat bawah sekali ni, kalau saya nak laju pun tak apa. Sebab my R will always be positive. So if I'm going really fast, my R will be really, really big. And I will feel like there's something on my shoulder pushing me into the seat. Rasa berat lah. Because my R is now super large. Okay. So tapi Ferris wheel selalunya tak laju kan. But it can be if it wants to at the bottom. Di kat atas, dia kena slow. Kalau tak, nanti semua orang mati. Okay. Next example. Oh, sorry. Ada soalan tak for this example?
Doctor,
Yep.
can doctor further explain why the R is higher, we will feel heavier? I'm confused about this.
Why R is higher when you are at the lowest position? Ke? Is that your question?
Why we will feel heavier when the R is super large?
Oh, why we feel heavy when R is super large? Okay. Because R ni, saya tak tahu cerita macam mana, tapi R ni is actually your perceived weight. Okay, kita ada weight kita yang sebenar-benarnya. Our actual weight is mg. Okay. Our actual weight is mg. But our body thinks that our R is our weight. Tak tahu kenapa. So when our R is equal to mg, when R equals to mg, kita rasa biasa je lah. Macam sekarang ni, I'm on my seat, my R equals to mg. I don't feel any added weight. However, when I'm moving really fast down this Ferris wheel, my R increases. So when my R increases, I will feel like, oh, my weight is increasing. I feel super heavy. Sebenarnya, my weight is still mg. Okay, but my perceived weight, weight yang saya rasa macam weight saya, tapi sebenarnya bukan, is R. That's just how our body is built. We feel like our R is our weight, but actually our weight is just mg. So when your R is super high, you feel like you become heavier. Tu je lah. Tu yang saya boleh explain because memang macam tu rasa dia. Okay. So if your R is super low, let's say you are, okay, nanti kita tengok example roller coaster
Okay.
Kalau dekat tengah-tengah doktor, like AC dia adalah 19 degrees to the R ataupun mg.
90 degrees. Oh, okay. Boleh tengok. 90 degrees. Oh, okay. Macam nak resolve tu? Sekejap. Saya punya eraser ni tak berfungsi. Jadi proceed way. Okay, so tadi Hakiman tanya tadi tu. So here what happened, AC is this way, but your R and your MG is here. Kan? Jadi apa? Saya pun tak tahu. How do you resolve your R?
Tak boleh kan doktor sebab R dengan MG tu Y, AC to X axis. So tak boleh sekali.
Y is X axis. Macam mana?
R dengan MG tu kan kat Y axis, AC tu X axis. So bukan X axis dengan Y axis, dia tak boleh cantum sekali.
Tak boleh lah. So AC tak ada komponen dari R dengan MG.
So kalau let's say kalau AC tu contohnya macam atas sikit ataupun dia ada macam ada degree. So dia boleh
Yes.
guna MG sign. So
Kalau kat
how about
sini,
that?
How about that? Okay. Faham? Kalau situasi macam ni, your MAC is just V squared over R tu lah. Whatever velocity that you are moving in and whatever radius is just MAC je lah. Kalau kita kat sini, sebab tak ada komponen yang acting in the AC direction. So your AC is just V squared over R. Okay. Kalau kita ada angle, let's say like this guy over here. Your AC is still pointing towards the center. It does not ever change. Memang towards the center at all times. So what happens now? So now you need to know what is the angle between your AC and your MG, theta. So this becomes MG cosine theta. And your R is apa? Ada sumbangan tak R ni? Kalau boleh resolve berapa ada lah. Sekejap. How do I resolve this? Macam ni boleh. Macam ni dapat.
Doctor, won't the vertical component be R cosine theta?
Won't the vertical component be R cosine theta? Why?
Very hard to explain, doctor.
Kejap. Saya define angle saya kat sini tau. So whatever that is touching my angle gets the cosine, right? Kalau saya define saya punya angle kat sini, then my MG cosine theta is here. Okay, depends on where you define your angle. So let's say your angle is there lah. Okay, contohnya. So this becomes MG sin theta. And if you get to resolve your R in this direction, contohnya lah. Saya tak tahu nak resolve macam mana. Saya tak nampak macam mana angle dia. Let's say lah ada komponen R cosine theta. Contoh tak ada saya tak tahu sebenarnya. So komponen R yang bergerak, komponen R yang boleh resolve in this direction, it will be in the equation. Okay, so let's say the R component in this direction is R cosine theta and the component from MG is MG sin theta. Contoh So your equation becomes FR MAC equals to R cosine theta plus MG sin theta. Tambah je lah dua-dua ni. That is your equation. If you get to resolve it in this direction. Okay, kalau tak ada contribution from R, then tak ada lah. So this guy tak ada. Okay, so it depends on the angle. Ada contribution ke tak ada. Saya pun tak pandai sangat geometri. So saya tak nampak kat sini. Boleh ke tak sebenarnya. Okay, so this is AC. Your MG obviously ada contribution. R ni saya tak sure. Saya rasa ada tapi sikit kot. Okay, so that is when you have an angle lah. But most of the time your question will focus on the top and the bottom. Bagi senang. Okay. Yep.
Boleh repeat balik tak yang kat top tu passenger feels apa, yang lowest tu passenger feel dan
Okay.
sebab apa?
Dan sebab apa? Sebab perceived weight lah.
R dia kan.
Okay, sekejap.
Nak pastikan balik.
Okay, at the highest point, okay, kita padanin dulu, ni confusing. Okay, at the highest point, your equation is minus mg sebab dia sama direction dengan AC, minus r sebab r is in the opposite direction. Okay, so MAC equals to mg minus r. So R, kalau kita rearrange this equation, R becomes mg minus mv squared over R. Okay, so if your V is, sekejap kita padam dulu yang ni. If your V is, let's say, 10 ke? Kita tak define weight kita lagi. Okay, let's say your R is positive lah, more than 0. Then you will feel, macam mana saya cakap ni? Sekejap kena pakai value ke tak? Okay, so point kat sini is, kalau saya nak saya punya R tu positif, my G has to be greater than V squared over R. Okay, tu point pertama, if I don't want to fall off. Okay, so if my R is very, very big, okay, my R will become very, very big. My R cannot be very, very big pun. My R is the biggest when it's mg. Okay, when my V equals to 0. Okay, kita padam balik. When is the maximum R? My maximum R is achieved when my V equals to 0. So it's R max equals to mg. So at this point, I can only feel macam tak ada apa-apa, macam my actual weight, which is nothing, or I can feel lighter. If I have velocity, if I have V is greater than 0, my R decreases, right? So I feel light. I feel light. I feel like I'm almost going to fly off because my weight, my perceived weight is now less than my actual weight. I feel like I'm terapung lah, macam rasa macam light lah, rasa macam tiba-tiba boleh terbang, rasa macam tu. When I'm at top. Yes.
So situation dia, dia lebih kurang macam kat lift lah.
Betul. Rasa macam tu. Kat atas tu kita rasa macam terbang, tapi kita still on the seat. Tapi kat bawah ni kita rasa macam kena tekan. Sebab kita punya perceived weight ataupun kita punya R is big. Okay, kat sini our R is either mg or less than mg. Sebab apa? Sebab R equals to mg minus mv squared over R. Kalau V sama dengan kosong, my R is mg. Kalau V saya ada value positif, my R is less than mg. Which means that I feel light. My perceived weight is lighter than my actual weight. Saya rasa macam nak terbang. Feel like macam perut saya ada rasa macam butterfly tu. Okay. At the lowest point. Okay, now let's talk about the lowest point. At the lowest point, kita punya equation, dia tak set kat bawah ni. Okay, at the lowest point, my equation, kita dah derive tadi. Fc equals to R minus mg. Okay. Fr MAC, okay, equals to R minus mg. Okay, so you're rearranging this, gets you MAC plus mg. Maksudnya your R, the smallest R that you can have is when your V equals to 0. When your V equals to 0, your R is just mg. When your V is greater than 0, your R is greater than mg. So you feel heavy. Okay, V equals to 0, R equals to mg. V is greater than 0, R is greater than mg. So you are heavy. Jadi when V equals to 0, R equals to mg. When V is greater than 0, R is less than mg. So you feel like flying. Tapi sebenarnya taklah, atas seat lagi lah. Kalau flying mati. Okay, is that clear? Okay ke?
Okay, betul.
Okay, yang penting kena tahu buat equation ni and free body diagram. Yes.
Doctor, for at the lowest point, the equation is R equals to mv squared divide R plus mg or minus mg.
Again, saya tulis sekejap. At the lowest point, my R.
At the lowest point, Fc is equals to R minus mg, right? So the R is Fc plus mg, right?
So R is MAC plus MG. Oh, kat lowest point okay. Ni salah ni. Oh, kat sini. Salah equation ni. Alamak, tak boleh edit. Kenapa? Don't know. Okay. So it's plus. Betul. Thank you. Thank you for noticing.
Okay, thank you, Doctor.
Okay. Okay. So everyone's okay with this example. Let's move on to the roller coaster. Okay. Tadi Ferris wheel, kita punya R was always upright. Now our R is bertukar-tukar, berubah. It changes with the motion. Why? Because our head is macam nak cakap macam roller coaster tu lah. Your head is here, dekat sini your head is here, kat sini your head is here. So your R is here, here, here. So it changes, okay? Because you are on your seat, your R is in the same direction as your perpendicular to your seat. So if your seat is this way, your R is here. Your seat is here. If your seat is over here, your R is here. So it depends how your seat is oriented. Okay. So that is the difference between Ferris wheel and roller coaster. So kena ingat this part kena ingat. Your R is different between a Ferris wheel and a roller coaster. So please baca soalan tu betul-betul. Is it a roller coaster or a Ferris wheel? Don't get confused about the R. Okay. So here your R is going downwards. At the highest point, your R is downward. It is in the same direction as your MG. Your weight is also downwards. Your AC is also in this direction. So again, your condition is FR equals to MAC equals to R, positive R plus MG. Dua-dua in the same direction as AC. This gives you equation MAC R plus MG. Rearranging this gives me mv squared over R minus mg. For me to not die on this roller coaster, my v squared over R needs to be greater than g. Okay, if my positive R lah. Okay, if my v is 0, let's say at the highest point my v is 0. Tak tahulah kenapa roller coaster tu tiba-tiba stop. So v equals to 0. What happens? R equals to minus mg. When we have a negative R, we die. Okay? We are no longer on the seat. So tak boleh lah. Roller coaster tu kena tutup sebab dah matikan orang. Okay? So for this, at the highest point, your V squared over R needs to be greater than G. Okay, at the lowest point, sama juga. You have your R pointing upwards, your MG pointing downwards. AC is towards the center of the circular motion. And FR equals to MAC. Comotnya. And then in the AC direction, positive R minus MG. R dalam sama direction as AC, so it becomes positive. MG terbalik, so it becomes negative. So MV squared over R plus MG equals to R. So at this point, I can go as fast as I want and I will not fall off. That is why when we are on a roller coaster yang bawah tu, when we go down, we are going at super high speed because we can, and we won't fall off. So that is why they do it at super speed bila kita ke bawah. And dekat atas, dekat bawah tu kita buat slow sebab kita boleh. Kat atas tu kita buat laju sebab kalau tak laju, jatuh. Terbalik pula. Okay, is that okay with everyone? At the highest point, you need high speed. At the lowest point, you can have low speed and you are okay. Okay? Okay, no questions? Okay.
Nat?
Yep.
This question may be a little out of topic, but why is the roller coaster not a perfect circle or almost circle shape? Because it looks a little oval.
Oh yeah, your roller coaster does not have to be a perfect circle. Remember the video lecture? We have a hill, blah, blah, blah. And obviously our hill is not a perfect circle, but we still assume a uniform.
Roll and duck.
Yeah, roll and duck, betul? Okay, so this is your AC and this is your AC. Okay, your hill is obviously not a perfect circle, tapi kita boleh approximate the centripetal acceleration like this. Sama juga macam ni. So we can approximate, Allah, nak tunjuk circle pun tak jadi. Okay, we can approximate that it is a circle walaupun it's an oval. So that is your how you approximate your centripetal acceleration. Physics is about approximation. Nothing is perfect in this world. Okay, you don't have perfect situations each time.
Jadi kalau macam tu, kalau radius dia nak guna yang mana? Contohnya let's say kalau macam kan bumi mengelilingi kan apa tu matahari kan dia oval kan. So radius tu kan ada beza. Jadi radius mana yang patut kita ambil? Like the yang paling panjang ke, yang paling pendek ke?
Oh, to be honest, saya tak tahu yang tu jawapan dia apa. Tapi untuk situasi macam ni, you draw whatever the circle punya drawing tu, kalau dia kasih radius macam tu, pakai je radius yang tu. Tapi yang untuk orbiting tu saya tak tahu sebenarnya. Saya tak pernah investigate pula. That's a good question though. Ini saya tengok. Kalau awak dapat jawapan pun awak beritahu saya. Saya tak tahu jawapan dia. Okay. So always just draw a circle. Tapi most of the time they will give you the circle diagram, let's say like this, and they will give you the radius. Okay? So they will draw you a perfect circle. If your roller coaster is oval ke or triangle ke, tak boleh triangle, like slightly membujur ke, they will give you that radius for you to use. Okay, so let's talk about what happens when we have our roller coaster is this way. Kenapa dia macam tu? Oh, seat dia macam tu. So your seat is this way and this is your R, your AC is also this way, your MG is this way. Assuming you know the angle between MG and R, how would you write this equation? Senang je, belagak gila. FR equals to MAC macam biasa. And then what is acting in the AC direction? It is positive R plus MG cosine theta. Remember, whatever touches the theta gets the cosine. So this guy, when I resolve it, becomes mg cosine theta. Ya Allah, buruknya. Let me write that again. So this guy, when I resolve it, when I resolve it, I assume that I know the angle. Why is this so bad? Sekejap. Boleh dah. Okay, so this is theta. So this becomes mg cosine theta. So R plus mg cosine theta is mv squared over R. Okay, rearrange that to solve for R. Macam biasa je. Okay, so roller coaster, I would say if you have an angle, it's easier to do because your R is always in the same direction. You only have to resolve for your mg. For Ferris wheel, it's a little bit harder. Okay, sebab your R and your mg is always just upright. So you have to know, you have to resolve it so that it's pointing towards your radial direction. Okay, it's all about resolving. Okay. Any questions for me before I show a video and then we will take 5?
Doctor,
Yep.
it may be a little late, but what V should we use in each question or it will be provided?
What V should be used in each question? You mean mv squared R punya V?
Yeah.
V tangential or whatever linear velocity that is given. So let's say dia cakap for the roller coaster, it is moving at a V of 70 meter per second. So that is your V tangential actually. And you should use that for your mv squared over R. Boleh? Okay, just pakai linear velocity for this guy. Okay, it's not going to give you omega. Kalau dia kasih omega, so you have to find your linear velocity lah. Sebab your mv squared over R tak ada omega. V equals to R omega. So if they give you omega, you solve omega equals to V over R. Balik. Just find R times omega. Okay, radius.
Omega tu like RPM, RPS,
Yes.
CPS tu.
Yep.
So dia tak doesn't matter dia CPS ke, dia RPS ke,
Matter,
RPM.
matter. Okay, kalau angular velocity awak, selalunya dia akan kasih angular velocity macam radians per second. Okay, so when you times it with radius, saya buat kat tempat lain lah. Okay, sekejap Okay, that's a good question. Okay. Let's use black. Okay, so tadi saya cakap the question will either give you V tangential, which is your linear velocity, which is just the regular velocity, which is V linear, or they can give you omega, which is your angular velocity. So untuk soalan macam ni, they will give you radians per second sebab dia bukan perfect circle. Macam mana saya cakap ni? Okay, just assume, just terima dulu buat masa ni, your angular velocity is given in radians per second. So to find the linear velocity, it's VR omega, right? So let's say this is 10. Your radius is also, your radius is 5. So your 5 meter times with 10 radian per second. Radian is actually, sorry nak cakap unitless, but usually you will just ignore the radian, so it becomes 50 meter per second. Okay, that's how you find out V R omega. Siapa tak tahu kenapa radius tu boleh radian tu boleh hilang. I can't say it's unitless.
Alright, so kalau macam ni kan, nanti kita akan masuk, dia suruh cari
Ni.
dia suruh cari FC betul? Centripetal.
Yes.
Centripetal force ialah mv kuasa 2 per r.
Yes. So V pakai yang ni, 50 ni, which is also this guy. Okay? You always use your linear velocity, your tangential velocity. Okay, is that okay? Okay, let's take 7 minutes of break before we go to the video. 7 minutes.
Hey, Dr. Nat, can you show the previous slide?
Previous slide. This one?
Yep. Give me a minute, doctor. Thank you.
Okay. Okay, you guys can take a break. Come back at 3:27.
Doktor.
Yep.
So kalau dia bagi kita apa-apa pun tangential.
Tangential.
Kalau dia bagi kita omega, memang kena pakai radian per second ke macam mana? Ke dia ambil je omega apa-apa dia bagi?
Kena tukar jadi radian per second. Apa nanti kita buat example. I think ada kot example ni.
Doktor ada list tak?
List apa?
Apa satu RPM berapa radian per second? Satu CPS berapa radian per second?
Oh kan kita dah cover dalam video tu ke tak?
Oh dalam tu ada tapi thank you.
Kalau dalam ni, sekejap. Oh tak ada. Okay, chapter 7 nak cover benda ni. So don't worry. Chapter 7 ada the revolution, conversion between CPS, CPM. Okay, jadi kita cover kat chapter 7 But for now, just know that you need to use the V tangential. That is all for chapter 6.
Dr. Nat.
Yep.
Sorry to disturb your break time, doctor. For V tangential, right, can we just use V as the symbol?
Yes.
So for chapter 6, it's safe to assume that V always means V tangential?
Yes.
Thank you, doctor.
Kalau dia bukan V tangent, kalau dia bukan V, it's not V tangential. It's omega dah terus. So V is always linear. V linear, this is angular. Memang V is just for tangential velocity or linear velocity. Apa nama dia? Betul. Oops. Video, centrifugation. What is centrifugation method? Whoa, sorry. When I lick it, stop sharing. Okay, let's do share screen. Share.
Dr. Nat. Dr. Nat.
Yep, I'm still here.
Sorry to disturb you again, doctor. I was trying to use the formula, the V tangential one, where we multiply omega with radius, and then like I want the unit radians meter per second.
Yes.
That's a correct unit.
I told you you will ignore the radian.
We just omit the unit to doctor.
Yeah. Apa nanti chapter
Oh,
7
okay.
we akan discuss in detail why it's possible to omit that.
That's why we just have to accept it for now.
Yes. So for now kena
Okay, thank you, doctor.
So chapter 7 nanti ada conversion convention. So I hope that's helpful nanti. Okay, is everyone back? It's 3:26. Oh, one more minute. Okay, is everyone back? Dah 3:27 dah ni. Okay. So I hope everyone's back. Okay. So now your lecture is this guy. Just kidding. Kita akan tengok centrifugation. It's an application of centripetal acceleration. So let's hear it. Sekejap. Sekejap,
Tak dengar doktor.
Oh, tak dengar.
Dr. Nat, it's not clear.
It's not clear. How do I make it clear? It's not, you mean the video is not clear?
We can hear the man talking, but it sounds like
Oh, it's muffled.
yes, muffled. That's right.
Macam saya nak tunjuk. Okay, let's mute it. Tak payahlah. Okay, so saya cerita You guys can hear me, right? Kan? Clear kan? Saya cakap.
Clear.
Clear,
Okay.
doktor.
Okay, thank you. Okay, so I'm going to explain. So here dia bagi tahu what happens if we have, okay, centrifugation is the process of separating substance. Dude, kenapa lah cepat sangat? Is the process of separating substances of different densities from a mixture with the help of a centrifugation or centrifuge. So basically it uses centripetal acceleration to spin the mixture, and then the mixture will separate based on the density. And why does it happen? Why is it possible to do this? Why is it possible to separate this? Because they have different density, which means that they have different masses. So their AC is also different. So that is how it's possible. Okay. So let's see. So here there is a cloudy mixture. Okay, so now it's going to accelerate these tubes to separate the particles in the water.
Doktor,
Yeah.
ni sama konsep yang kita nak tengok yang masa apa, darah tu ada plasma, ada hemoglobin.
Betul. Korang tengok Bio
Ya, Dr. Hani ada cerita sikit.
Oh, bukan cara untuk buat bionik ke?
Tapi belum tengok lagi.
Okay, so dia pakai physics lah untuk separate tu. Okay, kalau they use blood, they will separate plasma from apa
Red blood cell.
Oh, red blood cell. Okay, cool. Okay, so here because the particles have a different density than water, so they are separated. Okay. This is centripetal acceleration. Where is the radius of your centripetal acceleration over here? Where is it? Where is the radius?
From the center to the tube.
From here to here, right? Because this is your... mouse ni nak korang nampak tak?
Nampak.
Okay. So your circular motion is over here. Your radius is from here to here. So that is where your AC should be pointing, from here to here. Okay, so AC is from here to here. Circular motion is down here. So your AC is down here lah. Okay, so that's an application. Saja nak tunjuk sebab saya malas nak cerita banyak. Okay, so next one. So that's an application. Another one is electron orbiting the nucleus. So here we know that when we have a circular motion, we always have MAC, right? But we also have KQQ over R squared, which is the force acting in this direction between the charges. So here your equation is FR MAC, and there is also F due to charges, F charge, F electrostatic charge. So it's KQQ over R squared. Sama je?
Doktor, slide tu masih di YouTube.
Oh, kejap. Thank you for telling me. Oh, orang astronot.
Doctor, what is KQQ over R squared?
What is KQQ over R squared? Sekejap. Sekejap. Stop sharing. I want to share this over here. Okay. So Q is this charge, Q1, and then Q is this charge. Kita belajar ni semester 2 You don't have to know this equation yet. This is just macam example je. Okay, for you to relate. Okay, so radius R is just the radius between this guy and this guy. Radius. Okay, Q is charge 1, charge 2. K is a constant. Okay, you will learn this in more detail in next semester. This is saya nak tunjuk example je. So example of circular motion is centrifugation and electron orbiting the nucleus. Okay, all right, so let's move on to problem solving strategy. Read and understand, visualize and sketch the situation. Always identify the object in circular motion. Yes, like the pendulum bob, the car, test tube, okay? And then identify all forces acting on the object. So basically you have to draw your free body diagram. Okay, weight, normal, frictional force. Kena tahu question tu cakap frictionless ke, friction ke, okay? Tension of string or rope. So let's do a little recap, just mental recap. We have covered pendulum bob. This guy was tension and AC was this way, right? So you had to resolve T in this direction. So that was our first one. And then we also had a horizontal punya pendulum bob. Okay, so ni ada string. So T was equal to MAC. Yang ni tak boleh T equals to MAC because T has to be resolved. So it was T sine theta equals to MAC. Lain. This is when you have your circular motion in horizontal. This is when you have an angle. And then we also looked at circular path. You had a car. There was friction, and the friction was supplied by static friction. Static friction is pointing towards the center to give the circular motion, which means that MAC is equal to static friction. And then you also had a bank curve, right? And you had to resolve your mg and your r to know what your MAC was, to know what your FC was. Okay, so these are the different examples. You need to know the difference between them. And then you also had Ferris wheel. The thing to know about this one is your R is always upright, your mg is always down here. Your AC depends on where you are on the Ferris wheel. Okay, if you are over here, your AC is here, but your R is still over here, your mg is still over here. Roller coaster, your R is in the same direction as your AC. R is in the same direction as your FC. Your mg is this way. Okay, so banyak situasi, semua free body diagram. If you know your free body diagram well, you should not have any problem with this chapter. Okay. And then resolve all forces into the chosen axis. Your radial is your FR. And then this is F tangential or selalunya FY. Okay, it's in the tangential direction. It's always equal to 0 for our circular motion, unless dia saja nak complicatekan soalan. Tapi I doubt that's the case. So you just need to know your FR if you have a circular motion. And then do not forget your units. All right, so let's take a look at this example. Let me duplicate this first. Duplicate slide and buang. All right. So here we have a child mass of 25 kilogram. So my mass is 25 kilogram. Sitting 1.1 from the center. So I already know that my radius is 1.1 meter. Do I have to convert it? No, it's already in SI unit. Moves with a speed of 1.25 meter per second squared. So that is my V linear. Why is it my V linear? Why is it not omega?
because it's already meter per second.
Because it's meter per second.
Meter per second. If it's in radians per second or CPS or whatever, then it's not linear. Okay, so calculate the centripetal acceleration of the child. We know that AC equals to V squared over R. So we know this already. V is 1.25 R squared. R is 1.1. If I were to imagine this, if I were to sketch this would be 1.1 meter. I would be the child sitting over here. And then this would be my mass, mg. This is my R and this is my AC, pointing towards the center of the circular motion. Okay. The net horizontal force exerted on the child. So here the only net force is the only horizontal net force in my free body diagram is just FC, right? R does not contribute to my FC and my mg also does not contribute to my FC. Why? Because it is 90 degrees to FC. So dia tak boleh contribute lah, tak ada angle. Kalau 90 degrees dah tak boleh contribute. Tak boleh nak resolve. Okay, so FC just means that MAC lah. So this becomes 25 times with my AC, 0.25 squared over 1.1. So that is my horizontal net force exerted on the child, which is the centripetal acceleration, centripetal force. Okay, so tengok jawapan. Betul. V squared over R, 1.25 squared over 1.1 gives you 1.42. Then the net horizontal force exerted on the child is just FC. Okay. Senang kan? Soalan ni lah senang. Okay, so moving on, if there's no questions, next one. Oops, this one is a little bit. Oh, duplicate slide. This one. Okay. Oh. Okay. What is the maximum speed with which a 1050 kilogram car, so that's my mass, 1050 kilogram, can round a turn of radius 77. So it wants to round a radius of 77. Dia nak Okay. On a flat road. Okay, so it's just a flat road. So senang sikit kerja kita. So it's just this. And then, whoops. And then the radius from the car to the center of the circular motion is 77 meter. If the coefficient of static friction, so coefficient is mu s between the tires and the road is 0.8. So my mu is 0.8. Mu s is 0.8. Is this result independent of the mass of the car? Okay, so let's figure out the free body diagram first. So here, this is my car, and this is mg. I have R, and I have static friction parallel with the surface of the road. This is my Fs. What is Fs? It is mu R. Okay. What else? What is the maximum speed? So here we know that our Fr, our force in the radial direction, is MAC because we have circular motion. What is acting in the radial direction? It is static friction, which is mu R. And here we also know that Fy equals to 0 because we are not flying. Our car is not flying. It is on the surface and there is no movement upwards or movement downwards. So it is in equilibrium in the vertical direction. So this means that my R minus mg is 0, which means that my R is just equal to mg. Okay, so from here, my MAC equals to mu R. I'm substituting R with mg. Okay, so this is my equation now. So now it becomes mv squared over r equals to mu mg. My m can be cancelled out. I want to solve for my v because I'm finding out what is my maximum speed. So this equation becomes mu gr square root of that is v. So this is my v maximum. So that I can, this is the v maximum, so that my radius is 77. Okay, if my v is more than this, if my v, let's say, yeah, kita solve dulu So mu is 0.8 times 9.81 times the radius, which is 77. Square root of that gives me 0.8 times 9.81 times 77 is 604. Square root of that is 24.58. So my speed, my maximum speed should be 24.58 meter per second. What happens if my V is greater than my V max, than the V max over here? What happens if my V is, let's say, 26? What happens? Does anyone know?
Like
Tercampak R meningkat.
R meningkat. No, tak. Sebenarnya kita on the ground, kita tak tercampak pun. What happens to the okay, tengok equation ni. If your V max increases, what changes in this equation? Can your mu increase?
No.
No. Can your G increase? Tak boleh kan? So the only thing left is your radius, which means that your radius will increase if your V increases. So if your V is greater than 24.58, your radius is greater than 77. Okay, so that is why kalau the condition sekarang ni is to make a radius of 77. What is the maximum speed? Kalau lebih daripada tu, your radius will be more than 77, which is tak satisfactory lah sebab dia punya condition dia nak 77. Okay, does that make sense? Faham tak? Ke confused? Okay kan?
Betul.
Ya.
Dia memang takkan berlaku kalau V dia lagi besar tapi radius dia jadi kecil. Yang takkan berlaku. Yang mustahil. Dia memang impossible ke kalau V dia besar tapi radius dia boleh kecil.
Kalau V dia besar tapi radius dia kecil, which means that your surface is not 0.8. The coefficient of your surface and the tire is not 0.8 lah. Your coefficient kena tukar. Your surface tu kena tukar. Boleh je. Okay. Tapi untuk situasi ni, kena speed ni je yang maximum. This is the speed that you need to have to get a radius of 77. Okay. So tu jawapan yang pertama. Is this result independent of the mass of the car? Maksudnya kalau kereta tu dia punya weight jadi 2000, adakah jawapan berubah? Tak. Sebab apa? It's not dependent on M. Tak ada M dalam equation ni. So is this result independent of the mass of the car? Yes. The velocity does not depend on the mass. Sebab kita dah cancel out kat sini. So it's not dependent. Okay. Okay, any questions?
Dr. Nahat?
Yep.
That means as like the car is further away from the center of the track, so it needs a larger velocity.
Yep, betul.
Thank you, Doctor. Dr. Nat, one more question. Is this the same if it's like on a slope? If it's not horizontal?
No.
Okay. Thank you, Doctor.
You have to resolve your R and your MG. Lupa nak duplicate nasib baik. Okay, slide. Okay. Alright. Next example. A bucket of mass 2 kg is whirled in a vertical circle. Vertical circle maksudnya macam Ferris wheel. Dia circle tapi dia vertical, menegak. Saya nak cakap. Dia bukan horizontal lah. Horizontal macam ni kan. Dia vertical. Okay, so a bucket of mass 2 kg is whirled in a vertical circle of radius 1.1. So 1.1 je. Okay, 1.1. 1.1 meter. At the lowest point of its motion, the tension in the rope supporting the bucket is 25. Okay, so dia cakap kat sini, tension in the rope, this is your bucket over here. Bucket, so tension is pointing towards the center, so this is your tension. Okay, the tension in the rope supporting the bucket is 25 Newton at the lowest point. Okay, find the speed of the bucket. Okay, so your free body diagram, dia dah bagi tension equals to 25. You have mg. Do you have r? Do you have r?
No.
No, it's not on a surface. Okay, so situasi dia macam ni. You are at the center. Mana nak cakap? Macam mana dia boleh rotate macam tu? Macam Ferris wheel lah kot. So ni mesin lah kot. Okay, you can't do that. As a human, you can't do that. Okay, so you have a string. No, you don't have the string. The machine has a string and it rotates the bucket in a vertical circle. Okay, so dia macam ni lah. Moves like that. Okay, so bucket ni, will it change? Okay. Okay, so let's do this. Okay, so FR equals to MAC. Okay, macam biasa. Kita buat lowest point dulu . At the lowest point, we have T in the same direction as our AC. Okay, so T is positive minus mg. Okay, and then so this becomes MAC. MAC equals to T minus mg. This guy becomes mv squared over r. T is 25 minus mg. So tanya find the speed of the bucket. Okay. Find the speed of the bucket. Okay. Kita boleh solve for m. Okay. So this is 25. Your m is 2 times 9.81. And then you times this with your, so this becomes mv squared over r. So this becomes 2 times 9.81. 25 minus that gives me 5.38. Okay. Your r is 1.1 because that's the radius. You don't know your v, you know your mass. Okay, so your mass is 2, your r is 1.1, and then you have your v squared, which is 5.38. Solving for v gives you 5.38 times 1.1 divided by 2, and you square root that whole thing, you get your v as 1.72 meter per second. So that's your speed, your tangential speed. Okay, how fast must the bucket move at the top of the circle so that the rope does not go slack? So that the rope does not kendur lah kot. Tak jadi kendur. Kalau kendur, bucket tu jatuh lah kan. Okay, so how fast must the bucket move at the top? So it's asking, what is the V at the top so that the T does not kendur? Okay. So it satisfies a tension of the spring. Okay, actually I don't know what the answer is. I haven't seen this question. Okay, let's do this together. MAC at this point, your mg is here. You don't have r, and your t is also here. Your AC is also here. So here your equation becomes positive t plus mg equals to MAC. So T is equal to mv squared over r equals, mg. Siapa message saya? So this is 2v squared over r 1.1 minus 9.81. Wait. So lowest point.
Dia bukan sama ke doktor?
Apa dia?
Dia bukan sama.
T dia bukan sama T dia boleh sama ke? Tu saya tak tahu. How fast must the bucket move at the top of the circle so that the rope does not go slack? Does the T need to be equal? Actually, I don't know if the T is equal or not.
Doctor, T is the force exerted by the string on the bucket, right?
T is exerted. Macam mana lagi sekali? What was it, Bel?
No, because T is the force exerted by the string on the bucket, right?
Yeah.
So as the bucket is moved throughout the circle, shouldn't T be constant, Doctor?
Yeah, I should. Let's try. Kalau tak boleh solve lah. 25 Newton. Should it be constant if I am moving? Oh yeah, it should be. Betul-betul. Bel, you are right. The tension of the spring should be constant. Betul. Betul. Tadi pun
I hentam only.
But I think it's right. Sebab your tension does not change when you, right? Does it change? No, it does not change. Okay, so let's see. Betul tak jawapan dia? Did we equate? Yep, it equated T to 25. That is at the lowest. Sekejap. Tak lah. T equals to 0. Why? For the string to become slack, T is less than 0 or equal to 0. Okay, I don't know this one. Kenapa? I need to figure this out. Okay, this question.
I'm very sorry for misleading you, Doctor.
Okay, I thought it was 25. It's okay, so I'm gonna figure out why it's less or equal to 0. Macam reaction force pula. Not sure Okay, tak apa. We will discuss this in next class. Do we have another example? Oh, we are going for gravitational force. Okay, tak apa. So next class, we are going to discuss this question again. Why the T is less or equal to 0. And then we will discuss on gravitational force. And you should have already watched the video about gravitational force, because I'm going to go really fast. Okay?
Dr. Nat, for gravitational force, there are a few formulae which like the one where you have to add a height to the radius of the Earth.
Oh, yang tu confusing ke?
Kan, yang tu belum cover lagi.
Oh, okay. Yang dalam video tu dia cover radius je kan? Tak ada height kan?
Yes, Doctor, the traditional radius.
Okay. Yeah?
Doctor, I know why the tension is 0 and ke bawah.
Kenapa?
Tali untuk dia menjadi tegang, dia mesti ada tension.
Okay.
And soalan kata, berapakah halaju terakhir sebelum tali itu tidak tegang? So, tali yang tidak tegang tiada tension. Sebab tu dia kata tension dia kosong dan ke bawah.
Oh, ya. Yeah. Betul?
So, tali yang tak tegang tiada tension. So, memang paling minimum
0
untuk menjadikan tali itu tidak tegang, kita kena letak baru kita dapat V yang paling minimum.
Okay, betul. Macam betul je. Kelak. Betul. Nanti saya cek betul ke tak. Tapi saya rasa betul. Okay, good job. Wah, bangganya saya. Okay, so that's it for class today. I hope it was educational for you guys for the application. Okay, so I'll see you quiz pakai web assign je, so you won't see me on that day. So I'll see you next week. All the best for your quiz. And that's it from me. Okay. Any
Dr. Nat?
Yes, saya. Kenapa?
Oh, Dr. Nat, for the quiz kan, berapa soalan dan berapa lama?